Hey there kids, welcome to another math video. This is for Eureka Math, grade 5, module 4, lesson 25 homework. I'm like, what am I on? It's right there. So this one is kind of tough, so if you would like to, please go watch the problem set video first. I highly recommend you do that so that you kind of know what you're doing. Try to do this first. I know it can be confusing, but try. It's okay if you make mistakes. You can fix it when we start the video. So the objective is at the bottom as usual. Divide a whole number by a unit fraction. So today it starts out really easy because we're only using unit fractions. But in lesson 26, we start using, well, they still look like unit fractions, but you should be able to divide by non-unit fractions, which are fractions that have all kinds of numbers as your numerator and denominator, and also decimals. Anyway, so it's not going to be too bad. We do have to do a tape diagram and a number line to solve, but that's okay. We're going to make our number line part of the tape diagram. So hopefully you can get into it now and you'll understand what's happening. That's the most important thing. So if I have 3 divided by 1/3, then I'm going to take my tape diagram, okay, make the whole 3, divide it into 3 equal parts, call each part what it is as a 0 here, 1, 2, 3, that's your number line across the bottom. And then we're going to divide each one into thirds. Now this is what it looks like to start. If you would like to divide everything into pieces all the way, you'll actually get your answer because you can see how many pieces there are. So if this is 1/3, then you would just count how many there are. Also, it helps you to see how many thirds there are in one whole. There are 3. So then how many thirds are there in 3 wholes? You're just going to take your 3 times the number that you have. So it's 9/3 in 3 wholes. So 9/3 being this fraction, remember fractions as division, that's telling you the whole that you start with. So find the connection between all these numbers and words and things so that you understand what's happening here. Now, the second part of this is if 3 is 1/3. If 3 is 1 part out of 3, then what's the whole, question mark? That would be, of course, 3 times 3. So we're doing the same thing over and over. You're just needing to show it different ways, okay? So I hope that that's clear. That's kind of how you're supposed to put it together and show what's happening with your tape diagrams. So let's get further into it and we'll see how you did on your homework. All right, so 3 divided by 1/4. So we still have 3 here as our whole. So divided into 3, 0, 1, 2, 3. But this time, instead of 3 pieces, look at the denominator, it should be divided into 4 pieces. Each one makes fourths, 4 fourths in one whole. So how many fourths are there in, what are they saying? So now we're going to look at how many wholes do we have? Well, we still have 3 because that whole didn't change. But I do have a different number of pieces. And if you want to piece it out, you could see if this is 1/4 right here, how many little fourths would you have? It's going to be 4 of them times that. So you end up with 12. So 12 fourths in 3, and so that means that your final answer is 12 because that's how many pieces you've made in your tape diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There it is. Okay? Now, if 3 is 1 piece out of 4, if 3 is 1 out of 4, what's the whole? Just a different way of looking at it, getting the 12 this way with 3 times 4. Okay? Hopefully you got that one. Here we have 4 divided by 1/3. You have a new whole. it should go on top as 4, which means your number line on the bottom, count to 4. It's divided, each one is divided into thirds. So this is 1/3 here. And so how many thirds are in one whole? 3/3. 1/3 plus 1/3 plus 1/3 makes 3/3. That goes there. And then there are how many thirds in how many wholes? Well, again, what is your whole? WHOLE. That is the dividend that comes first. That's what they're telling you. That's why it goes there. And so how many little pieces are there? When you add up the 3 times 4, you get 12. Now, if 4 is 1 out of 3 pieces, what is the whole question mark on top? 4 times 3. And you get 12 again. Okay, so last one on the front. We have our 5 is our whole. And so number line 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. Each one is divided into 4 parts. So this is 1/4. So how many little fourths are there in one whole? 1, 2, 3, 4, 4 fourths. 4 fourths make 1. So 4 times 5 make 20. So there are how many fourths in what's your whole? And there are how many? 20 fourths in 5 wholes. So for the next, that's a crazy one. For the next one, if 5 is 1 out of 4 parts, what is the whole? 5, 10, 15, 20, 5 times 4. So if you're understanding how these go together, then, sorry, I didn't put the answer. Fill that in. If you understand how they're going together, then you should understand when we do our old-fashioned, my favorite way, keep it, change it, flip it, which is the multiply by the reciprocal, which is how your parents understand dividing fractions, because we all learned the same way, and it was just using the shortcut. Okay, so here we have our divide, then multiply to check. So I want you to put, if you're in my homeroom class, we have our classic, the OG, we've got our classic way of solving here, which is going to be the old way, which we love because it's so easy. So we're going to do that first before we actually follow the directions. If you're just a subscriber and you're not in my class, this is probably extra, but it's really central to understanding this whole lesson. So we're going to keep the original whole, which we never can move because this is a division problem. But because you do the opposite operation with the opposite or the reciprocal, we know we're going to get 8 as our answer. So right now, we're going to have all of our answers so quickly solved. Keep it, change it, flip it, answer. Keep it, change it, multiply by the reciprocal, answer. Keep the whole, change the sign, flip the second fraction, there's your answer. This is how many pieces you're going to have of this size fraction in each of the wholes. That's what that final number means. Keep it, change the sign, flip it, multiply, done. Keep, change, flip, multiply. Keep, change, flip, multiply. Keep, change, flip, multiply. Now, why is this possible? Okay, this is the old way. Your parents say this is good enough, and probably I know our 6th grade math teacher is like, this is all they need to know. Okay, but for the Common Core people and everybody who really wants to follow these directions, you do kind of have to know it. You might be tested on it, so here it is. You have to have a number that you can divide with. If 2 is over 1, I cannot divide 1 by 4. So we have to at least make this 4. How can I get that there? By scaling by 4. So I have to multiply this by a scale factor of 4. 2 times 4 is 8. 4 times 1 is 4. 8 divided by 4 still equals 2. That's why it works. We're still dividing by 1/4. Divide across. 8 divided by 1 is 8. 4 divided by 4 is 1. 8 divided by 1 is 8. And so that's my answer. This way is a little bit more work because you have to get this equivalent fraction that has more pieces, so I can divide it with that 4 denominator. Then, as if that wasn't enough fun, we get to multiply to check. So you take your answer, which is 8 over 1, and you're going to multiply it by your divisor, which is 1/4. Now we know how to multiply, and this is good review. 8 times 1 is 8. 1 times 4 is 4. 8 divided by 4 is 2. And when you get that, you should end up with what you started with. And so that's just proving that when you take 2 apart and put it into fourths, you'll get 8 of those fourth size pieces. And then we multiply to check. So we're putting it back. So it's a lot more work. It's a lot more complicated when I'm just saying, hey, the classic way, if you want to know how many fourths there are in 2, there are 8 fourths in 2. And you can do it this way. So let's do all the work. Okay? Now, if 6 over 1 needs to be divided by 2, I only need to make this a 2. So my scale factor is 2. 2 times 6 is 12. 2 times 1 is 2. 12 divided by 2 is still 6. So I still have an equivalent fraction, 2, 6. Okay? Keep this one the same because all I did was change this fraction so that I could divide. 12 divided by 1 is 12. 2 divided by 2 is 1. 12 ones is 12, and there's that answer again, running out of room. So take your 12 over 1, multiply to check, multiply by 1/2, multiply across, divide this, and you're back. Okay? So, got to have at least a 4 here. Use 4 as your scale factor. 5 times 4 is 20. 4 times 1 is 4. Divide by 1/4. 20 divided by 1 is 20. 4 divided by 4 is 1. 20 is my answer, which I already knew. And I already knew that one too. Take your 20 over 1, multiply to check. Multiply by 1/4, multiply across, divide, and you're back. Okay, 5 over 1. I need something that is at least 8. Let's use 8 as our scale factor. 8 times 5 is 40. 8 times 1 is 8. 40 divided by 8 is still 5, so that's equivalent. Divide this by 1/8. 40 divided by 1 is 40. 8 divided by 8 is 1. I got 40, which I knew I should get. Now let's multiply to check. Multiply across, and across again. Divide this, and we're back to where we started. Okay, so see how it takes a lot longer to do it this way? This is why nobody divides with fractions. Nobody. Okay, we need at least 3. Use a scale factor of 3. What if I don't write the scale factor since we're short on room? Will you understand that that is in my head? So 3 times 6 is 18. 3 times 1 is 3. Divide by 1/3. 18 divided by 1. 3 divided by 3 is 1. We finish with 18, which is what we needed to get to. Multiply to check. Multiply across. Divide. We're back. Okay, got to have a 6 here. That's your scale factor. 18 over 6. Still equal to 3. Oops, not equal, but got to divide here. 18/6 divided by 1/6. Divide here. Divide here. You get 18. We knew we needed that. Multiply to check. 18 times 1/6. Multiply across, divide, we're back. 5 is the scale factor. Make an equivalent fraction. 30/5 divided by 1/5. Divide 30 by 1 and get 30. Divide 5 by 5 and get 1. That's 30. Check with multiplication. Multiply across and across again. 30 divided by 5 is 6, and we're back. Finally, use 10 as your scale factor. Multiply by 10 and get 60/10, which is 6 divided by 1/10. So 60 divided by 1 is 60. 10 divided by 10 is 1. That gives us 60 as our final answer, which we knew. Multiply to check. Times 1/10. Multiply across, divide, and we're back. Okay? So I know that's a lot of work, but if you understand everything that I just did 8 times, then you will understand dividing with fractions. Okay, here we have 2 word problems. A principal orders 8 sub sandwiches for a teacher's meeting. She cuts the subs into thirds and puts the mini subs onto a tray. How many mini subs are on the tray? Now you can make a tape diagram if you'd like and call this the 8 subs, and you can even separate it into all the pieces that we would in a normal situation. You can turn it into a number line like we did on the previous page. Okay, now each one of these is divided into thirds, which means you don't actually have 8 sandwiches. You have 8 times 3 sandwiches, okay? Because each person isn't going to get a full sandwich. They're each going to get 1/3. So we have 8 divided by thirds. So that's how you kind of want to set it up. I automatically would say this is our whole, multiply by the reciprocal, and you have your answer. Okay. Oh yeah. Hello, lights. There we go. So if you have your answer, you're good. If you want to do it the division way, you go right ahead, because we just did it 8 times and you should know how. This is how I'm going to do it, because I know I can multiply by the reciprocal and get my answer that way. Here we have some students prepare 3 different snacks. They make 1/8 pound bags of nut mix, so this is going to go with that one, 1/4 pound bags of cherries, and then 1/6 pound bags of dried fruit. If they buy 3 pounds of nut mix, 5 pounds cherries, and 4 pounds of dried fruit, boop, how many of each type of snack bag will they be able to make? So just keep your work organized and then figure out what's being divided. So take your 3 pounds of nut mix, that's 3 being divided into 1/8. This is the nut mix. Okay, and then we've got 1/4 pound bags of cherries, and we have 5 pounds of cherries divided into 1/4 pound bags. And then we have the dried fruit, which is 4 pounds in 1/6 pound bags. So now you have everything set up. Don't forget to always write the expression when you start. Always set it up with your original division. Do not try to jump right into the keep it, change it, flip it. I guarantee at some point you're going to forget what you're multiplying or dividing. So set it up so that you know this is the whole, this is what you're doing with it, and now you can keep it, change it, multiply by the reciprocal, and have 24 bags of nut mix. Okay, the 1/4 pound, that's for the cherries. So that is going to be 5, keep it, change it, flip it, 20 bags of cherries. And our final dried fruit. DF. There we go. Keep it, change it, flip it, multiply 24 bags of dried fruit. Don't forget to click subscribe. Thanks for coming today. These are the answers for number 4. How many of each type of bag will they be able to make? And there you go. So I know that was a big lesson, lots of important stuff. I hope this was helpful. Come back again. See you again soon, y'all. Bye.